Good morning or good afternoon, depending on when you're calling from. Please welcome to today's live session. Today, we are privileged to have colleagues from AfriGIS who will do a presentation of some of the work. And in today's presentation, we have Yajemi from AfriGIS, and he will present on how we can download data and stream that data in QGIS from Digital Africa. So AfriGIS to be able to demonstrate how to access the Digital Africa web services in QGIS, including the web map services, web catalog, and how you can actually be able to download, which is very key to streamlining your workflows. Welcome, and over to Mr. Yajemi. Welcome, everybody.
Hello, Ken. Hello, everyone. I hope you are doing good. The presentation of today is on downloading and streaming data to QGIS. Most of the natural and the regular way of downloading data is to go to a specific site, get the data and download them on your PC. But sometimes your PC and the rate at which you download is very slow, and also you need the data, a high level of data, so that I can be able to download. But with this, we are trying to stream the data straight from the Digital Earth Africa platform to the QGIS. So that is the procedure, how we can do it, that I will show in this presentation. Presentation, we know already Digital Africa. We talk about the vision of Digital Earth Africa that provides a routine, reliable, and operational services using Earth observation to deliver the already products, enabling policymakers, scientists, the private sector, and civil society to address social, environmental, and economic changes on the continent and develop an ecosystem for innovation across sectors. We have the agricultural and food security sector, the water resources and flood risk sector, the land degradation sector, the urbanization, and the coastal erosion. So, to be able to view data on Digital Earth Africa, we can move straight to Digital Earth Africa map. That we have the site address that is here that you click on, and it takes you direct to Digital Earth Africa map. You can view the data, choose which data you want to use, whether it's Sentinel, or whether it's Landsat, or whether it's the GeoMax. On another way, we can analyze the data from Digital Earth Africa. We are to go into the Digital Earth Africa sandbox using the sandbox URL related to sandbox Digital Earth Africa. And we access, we can access other platform that includes the OW map service, Digital Earth Africa learning platform. We will talk about it. Now, we are talking about the Digital Earth Africa overview. Digital Earth Africa overview enable us to do the data storage, to explore, to access the metadata. And also, when talking about access metadata, we use the spatio-temporal access catalog, that is STAC. What are the benefits of STAC? You have the standardized geospatial description that facilitates quick identification of data by product location or time period, allowing for efficient downloads or streaming into QGIS. And this GIS software we are using here in QGIS. The STAC overview. As I said previously, that the STAC is the spatio-temporal access catalog. That is the definition of what we call STAC. It's a new specification for describing geospatial information, facilitating easier indexing and discovery. Functionality of the STAC. Digital Earth Africa STAC metadata enable quick identification of available data based on product, location, or time periods. To use this metadata supports efficient downloading of data to local storage or direct streaming into desktop GIS software like QGIS. The objective of this presentation is to be able to provide a notebook, is to be able to construct a STAC metadata API call how to search for stack metadata and load the result into Python, how to inspect and plot the unique stack item content in the metadata, how to inspect asset content within a stack item, how to download data using stack metadata, how to stream data into QGIS using stack metadata without downloading it first. That is what we do previously before. We download the data first before we start using it in QGIS. But this time around, we are going to get the URL of those of the data that will bring it straight to QGIS, and we can be able to download it. Stream it, let's say stream it straight. The methodology using this is to load the packet. This is a script. So the script that provides all those, what we said previously, we are in the method of doing it, we have to load the package. The load the package means that we are going to load all the necessary library that will help us to process the data, analyze the data. We connect to data cube. We search the stack metadata. Under the searching of data metadata, we construct the stack API call. We load the stack metadata. After that, we inspect the stack item. We inspect the assets. We download file using the stack and stream data into QGIS. So to load the data package, we import Python packages that are used for the analysis. We import the OS, we import the data cube, we import the URL library requests, we import the GeoPenda, import the array, sorry. We import ODC, AWS from pprints, import pprints, and we also load data cube test util.io import rio slash let's say actually where we are going to the code we are going to use to be able to import our iro and the array. We connect to the data cube. That is the first thing we do when we are working with the sandbox, when we're working with the sandbox of data at Africa. You have to connect to data cube where the data that we are going to use are located. Now, after connecting, now we are going to search for the stack metadata. In searching the stack metadata, we construct the stack API call. To construct the stack API call, first of all, we need to set up some analysis parameters that will be used to search for metadata. This includes products, which is the same product name used to load data directly using DC load. So when we want to load the data, we use the DC load. That is the code. In this example, we choose a small area over Ile-Ife, Osun State in Nigeria. So if you want to get a full list of available products, browse the Digital Earth Africa Sandbox Explorer. So for the parameters we are going to use to be able to extract our area, we are going to use the product Sentinel-2. The starting time is the 1st January 2020, and the end time is the 31st of January 2020. And the bounding box we are going to use have the longitude and latitude that is showing on the screen. Now combine the parameters above to create a URL that will be used to query Digital Earth Africa stack metadata. This metadata can be previewed in another tab by clicking the URL. That's the code that we are going to use. And when we print the stack URL, the stack URL that is showing down, HTTPS and co. After that, we can now load metadata from the URL above into Python. What do you mean by the URL above? You know, when we print our URL, that is what we show on the back of the code. Under the code, that's what we see. So then here now, we are going to combine the parameters to create the URL that will be used to query Digital Earth Africa stack metadata. This metadata can be previewed in another tab by clicking the URL. Okay. So we are the one that we choose. If you click on URL, it will ask you where do you want to preview this URL, and you can choose where you want to choose it to. So it can be different from Earth Africa, digital Earth Africa, stack metadata site. When we load the stack metadata, we can now load metadata from URL above into Python. Stack metadata is stored in JSON format, which we can read into nested Python dictionary using the JSON Python module. Library .expect.url opens. You have the data, and we print that data. When printing the data, those are the information that we get: the content, the picture, the link, the number of match, the number returned, and the type of feature collection. Now, when expecting the track item, from what we did last, you have the outputs that came above that shows the number return value indicates our search returns 6 unique results. These results are known as stack items. Those are the elements that are in this stack that we wanted to get information from. These are anatomy collection of inseparable data and metadata such as a unique satellite dataset. Data for each stack item is contained in the metadata list of features. We pre-print the data, and so we are going to get the following information: asset, the bounding box, the collection, the geometry that we use, the property, the stack extension, the stack direction, the type of feature, the asset, the bbox, the geometry. Because we talk about 6 features, we return 6 information for us. Those are the information concerning those 6 features that we have here. Stack features are stored as JSON, a widely used format file for storing geospatial vector data. This means that we can easily convert it to a spatial object using the QGIS Python module. This allows us to plot and inspect the spatial essence of our data. It allows us to be able to our own area of interest. Now we convert our feature to a geodata frame, because we said that stack feature are stored as GeoJSON, a widely used file format for storing geospatial vector data. So that data has to be converted into spatial objects, where we are going to use the QGIS Python that we loaded previously in our. This allows us to plot and inspect the spatial extent of our data. This is the spatial extent of our data from 3.50 or 3.40 going to 5.50. That is the Y, and our X move from 7 to 750, 850. If we play the geodata frame itself, we can see that it contains useful metadata field that provides information about each data set. You have the geometry, the title, the GSP, the GSP, the ESG, the project EPSG, the platform, the view, is it of Nadir or not? It will show us the instruments that are being used. We can use this to learn more about how data, for example, we can plot our data using the cloud cover field to show what percentage of each data set was obscured by cloud. So this will definitely allow us to not use the area that have been covered with cloud. So with the code below, we can be able to show from our, in fact, in terms of the time, we know it, we talk about the time, 1st January 2020, and the end time 31st of January 2020. So we are trying to check whether during that period our area is covered with clouds. So this is the code we are going to use. And the yellow shows that there's a high. When we have on our legend by our right, we see that the yellow color is showing that the highest area that we cover by the coded area that we cover by the cloud. And the one that is green is 40% of our cloud cover. And the one that is violet shows us that there's no cloud cover actually. So I think we are going to discuss the area where the cloud cover is more than 40%. Let's say from about 25%, we are not going to use that area. So we are going to write another BB box so that we can be able to choose from the picture by your right. You see the frame by your right showing that from 350 to 545, for example. That is what we are showing in terms of the latitude. And from the longitude, we are going to choose from 740 to 820 maybe. And each stack item listed in feature can contain multiple assets. This asset represents unique data files or layer. For example, individual remote sensing bands for digital Earth Africa Satellite 2 product. This can include the band metadata, the band, the metadata, etc. So we want to list the feature that can be contained in the product that we choose. And most of the time, you know what we call metadata. Metadata is where all the information concerning the product that we want to use are stored. So we want to extract those information from data, our metadata. These are the information that we get from our products, showing that the different bands that we have, this is different information that we have, the metadata information, the overview, the thumbnail, and the visual. So each asset, for example, we would take the band 5, provides a unique URL that can be used to access or download the data, in this case, the S3. The prefix indicates our data is stored in the cloud on Amazon S3. That's the S3. So it's telling us that our data is stored in the cloud on Amazon S3. So we print the stack item and of the band 5. You have the name of the band, the type of the image, the role, the projection, the transformation of the projection and the shape of the projection, and the coordinate system, and the band name. Now, when we get the URL of that band, we can use this to download data to our local disk. For example, we may want to download data for the band 5 satellite bands in our stack item. We can do this using the S3 download function from odc.aws. Down is the code that have been used to download to get the URL of that band 5. To verify that this file downloaded correctly, we can load it into our notebook as an sra.dataset using the riosra.open. To do that, we load the data as an array dataset, an sra dataset. Sorry. So when we load it, now we download, and later we plot the small subset of data that we've chosen. When I told you that there are some areas that have been covered by the cloud, that we now remove those areas from our area of study so that we won't have any problem. We will have a data of cloud free, and we know it, and we have shown you already in the previous slide. So downloading the file using Stack, we know the URL that we use of the band 5. Now we have an example here of the band 1. That is what we get as an image on that our script. If this notebook is being run on the Digital Earth Africa standard, the save file will appear in the pre-country use code directly in the Jupyter Lab file browser. To save it to your local PC, right-click on the file and click Downloads. You can even download the multiple files. To download data from the band 5 for each of the 6 stack items returned by our search, we get the list of all our URLs for the band 05, that is band 5 that is band 5. We download each URL. For this, we print the URL, and to download all available bands for a single stack item, we use the code below. Later, we are still on the streaming of that satellite data that we are doing. So the overview that the challenge we are going to face in downloading data is that last satellite data, when we download it directly to our local disk, can be slow and time consuming, as I said at the beginning of the presentation. So what we need so that we can be able to download those data easily and rapidly. So the solution is the streaming data directly from the cloud that can be more efficient, especially for cloud optimized GeoTIFF format, which allows for streaming small image chunks at a time. Implementation. This session demonstrates how to stream data directly into QGIS software. The first step for that is we have to convert the Amazon SR3 URL into HTTPS format so that it can be read more easily. So this is the code that we use so that we can convert the data that is coming from Amazon SR3 into HTTPS format. So when streaming the data, this is what we get. Those are it for the band 3, band 4, and band 5. To stream data directly into QGIS software like QGIS without having to download it first, we select and copy the HTTPS URL above that we collected, we get to our clipboard. Then open the QGIS in QGIS, we click on layer, we add layer and add raster layer, as is shown by our rights. After then, we open data source managers. In the QGIS right, we open data source manager, and there's a raster dialog. When we have the raster dialog showing that we have the source type, which source are we using? We are not going to download it in our system, so we are going to get it through the protocol. So we click on protocol to select protocol, and we ensure that we type the HTTP, HTTPS, and the FTP, and paste the URL into the URL bus. You can see it here. After that, we click add, and then we close after a few moments. The image we identify using Stack will appear on the map. This data is being streamed directly from the cloud. No downloading required. That's what we do for all the band 1, band 5, band 4, and band 3. We choose it because we are going to do the image composite and be able to continue to do our work so that the work will continue either in QGIS or if you want, but the purpose of this work is continuing with QGIS. Then we open our project. We click on raster on the main menu. In the drop-down window, we click on miscellaneous, and then unmute virtual raster. A new window will open. That new window will allow us to create our virtual raster. So we click on the parameter tab and click on the button of input layers. When we click on the button of input, we select the data we want to add. Here we have only the 3 bands that we selected, so we select the band 3, band 4, and band 5. After then, we tick on the place each input file into a separate file, if at all it has not been ticked before. And also we make sure that the open out file after running algorithm is being ticked. We run the process. After the process is completed, we close the window. This is the process has been completed here. And then we close it. So later, our completion, you will see the visual image on the next slide. This is the visual image of our color composite image. That means the image you are seeing in the virtual, that means that you have to save it in your system now. Save it in your system so that you can be able to continue the work, because the image we have here is virtual. So thank you very much for listening. To download the notebook of this presentation, this is the link that will allow you to download the notebook so that you can be able to work on it, apply it on yourself and see on your area and see how it looks like, how you can download the data of your own area. Thank you very much. We know that the Digital Africa training course is always in English and French. Next week, we are going to have the French version of this presentation. So this training in this is a self-paced, free to access, fully online, video recorded tutorials, manuals, hands-on exercises, English and French version. Certificate of completion is awarded upon completion of exercises. We have to connect with Digital Africa, which we want to collect when we are talking about the digital website. We have a digitalearthafrica.org. We have some other opportunities to read, to go to the Sunbox, to go to the map, and so on and so forth. And so there are some links here that will take you to our weekly live session. Thank you very much. These are our partners. Thank you very much.